ሰላም ሰላም እንዴት ናችሁ? ዛሬ ከብዙ ጊዜ ቆይታ በኋላ ተመልሻለሁ። ዛሬ ስመለስ ይዤላችሁ የቀረብኩት ቤዚክ ማትማቲክስ ፎር ናቹራል ሳይንስ ሚድ ኤግዛም ሶሉሽን ነው። ይሄ ሚድ ኤግዛም የተዘጋጀው በጎንደር ዩኒቨርሲቲ ሂሳብ መምህራን በጎንደር ዩኒቨርሲቲ ለሚማሩ ፍሬሽማን ተማሪዎች ነው። ስለዚህ በቀጥታ ወደ ጥያቄዎቹ እንሄዳለን። በቀጥታ ወደ ጥያቄዎቹ ከመሄዳችን በፊት ምናልባት ለዚህ ቻናል አዲስ የሆናችሁ ሰዎች ካላችሁ ቻናሉን ሰብስክራይብ በማድረግ እና ይህን ቪዲዮም ላይክ በማድረግ ብትጀምሩ ደስ ይለኛል። ወደ ጥያቄዎቹ ስንሄድ this question paper is containing about four question types or items. The first part is true false item. Second one is multiple choice item. Fill them blank, and the last one, or simply the fourth part of this question, could be workout problems containing about two problems. So when we proceed, the first question of the first part of this question, that is this one. I think this one is not here. So the question says, the truth value for a x, an element of R, directs to y, an element of R, satisfying that is x times y is equal to 3, is blank. We know that this will be true if and only for every number x, if we can find the corresponding y within the same set that's simply a real number, satisfying this condition, so that the statement will become true. But if we can obtain at least one element that's simply 1x, which doesn't have any corresponding y satisfying this condition, so that the statement will become false. And now we know that for any real number x, we can choose, for example, that's simply y, which is equal to 3 over x, for x different from that of 0. So that if we do have x here, and if we choose y is equal to 3 over x, the product will become 3, but this holds true whenever x is non-zero. But when x is equal to 0, 0 times y is equal to 3 has no solution for any y. Or there is no any y that's simply y, satisfying or simply making this statement true. Therefore, because of the existence of this one that's simply 0, which is a counterexample without any corresponding y satisfying this condition, so that the statement that's simply the truth value of this one that's for every x an element of R, there is a corresponding y an element of R satisfying this condition will be false. So that the answer for the first question is false. The second one could be, the second question could be this one, that simply the statement is, for any set a symmetric difference empty set is equal to A. So that in order to check the truthness of this one, we have to know the property of the operation that is simply truth value, symmetric difference. We know that for a symmetric difference between any two sets and that of B, a symmetric difference B will be obtained by using the formula A without B, that is A minus B union B without A. But here we are given that is A in the empty set, so that if we substitute empty set for B here, so that asymmetric difference empty set is equal to A without empty set union empty set without A. But we know that A without empty set is A, and empty set without A is also empty set, so that the union of these two will be A. Therefore, for any set that's simply any type of set that's simply set A, asymmetric difference empty set is always the set itself that is set A. So that the truth value for this one could be, that is true. The next one, that is question number 3. For any set A and B, number of A is equal to number of B implies A is equal to B. We know that the equality of two sets that is simply A is equal to B. Even though having the same number of elements for the given sets is one condition, one necessary condition for the two sets to be equal sets, but only having the same number of elements of the elements doesn't imply this one, that is the equality of status. That is, equal cardinality doesn't imply equal status. Let us verify this one by considering simple example. Let's assume that A is containing two elements, 1 and 2, and B is same number of elements, but whose elements are A and B. We know that A and that of B have the same number of elements, but as you observe clearly here, these two sets A and that of B are not equal sets. Therefore, from this we can conclude that they having the same number of elements doesn't imply, or simply there is not a sufficient condition for the two sets to be equal. Therefore, automatically this statement will be false. The next one, that is question number 4. The number of non-empty subsets of finite set E is to the power of n of E, where n of E is the number of elements of the set, that is set E. You know that in order to calculate or simply know the number of non-empty subsets of a given finite set, we know that all the possible subsets of the given set, that's simply finite set E, will be obtained by using that of the formula, that is to the power of n of E, where n of E stands for the number of elements of the given set E. But what we are given here is, or what we are asked here is, we are asked just to know the number of non-empty subsets of the given set. We know that this within this formula, that is to the power of the number of elements of the given set, it is including the empty set. But we are asked the non-empty subsets of the given set, so that we should exclude empty set from being considered here. So that in order to exclude this one, so that the correct formula for this one could be to the power of n of E minus 1. We are subtracting 1 because just to exclude empty set from being an element of the subsets of the given set. Because we are given, or simply we are asked just to find the number of non-empty subsets of the given finite set. Therefore, the correct formula is this one, so that the statement is false. The next one, question number 5. The converse of the statement, that is the wages are low if there are price controllers, is there are the price controllers if the wages are low. Here we know that it is we are given that simply the logical implication, that is the wages are low if there are price controllers. This could be originally written as, if there are price controllers, then the wages are low. The wages are low. So that let's find first the original statement. The original statement for this one could be, if there are price controllers, then the wages are low. So that easily the converse, the inverse and the contrapositive of this statement will be obtained correctly. We know that the converse of the given statement will be obtained by interchanging the position of the two, that's simply P and Q. That means we can take this one, that is simply the wages in the if statement, and the if statement of the original statement, that is there are price controllers, to be the conclusion for the converse. Therefore, when we do this interchanging, we have the converse of this statement, that is if wages are low, then there are price controllers, which is identical with there are price controllers if the wages are low. Therefore, there are price controllers if the wages are low is exactly the converse for the statement that the wages are low if there are price control. Therefore, the statement is true. That is the correct form. That is, the statement is a true statement. The next one is the first question of second part. that is a multiple choice item. The first question would be, which one of the following statement is an open proposition? Remember the definition of open proposition. It is a proposition by itself, which involves one or what more variables. But when we replace the variable, automatically the proposition will be the proposition will be answered by the truth value will becomes either true or that false. But this doesn't imply that every statement involving a variable is an open statement. It depends, that means. So we have let us see the options. The first option says x plus 1 is equal to x for every x. It's not open, it's closed because it is always false. That means it is false because there are at least one element that cannot satisfy this condition, so that there is false statement. That means the truth value of this one will never depend on the value of this one, that's simply x. The second one could be this one, that's x plus 1 is equal to 0. It is an open statement because the truth value of this one will depend exactly on the variable that is x. When we replace the variable that is x by a certain individual, so that the statement will be either true or that false depending on the value that we are going to replace, or simply that we use just to replace the variable that is x. So that is an open statement. The next one is x plus 1 is less than x. It's not open, it's closed. Because here x plus 1 less than x is always this one, that's a false statement for every x. Therefore, it is closed. That is, the truth value will never depend on the value that is x. And lastly, that is D. It is all, that is all A, B, and that of C are correct. That is, they are open statements, which is incorrect. So that the only correct form of this one, that simple open statement will be, that is B, which is x plus 1 is equal to 0. So that the answer for this statement will be, that is B, alternative B, which is x plus 1 is equal to 0. Is open, but the rest are not open, or simply they are closed. The next question is question number 2. If P, Q, and R denote the propositions, then which of the following is equivalent to P implies Q or R? We have three component statements here, and we have this logical implication. So that what we are asking here is, we are asked just to select from the following that simply, which is equivalent to that of this one. You know what equivalents are. Therefore, the solution will be, we have a P, we have P implies Q or R, which is negation of Q, or Q, negation of P or Q or R. We know this one, I think that's simply just if we have P implies Q, so that negation of Q or negation of P or Q will be equivalent to that of P implies Q. So that when we do this, taking the negation of this one, and the implication will be converted into this one, that's simply or, so that there is equivalent to that of this one, that's simply negation of P or Q or R. Then checking option, that is the first option, that's simply A. Negation of Q implies negation of P or R is equivalent to, that is taking the negation of this one will be, the negation of negation will be Q. And this one, that simply the implication will be converted into OR. So that this one, that's simply the proposition, or simply the logical disjunction, which is enclosed by the bracket, will not be changed. So that is identical with this one, that's simply Q or negation of P or Q. Because of the commutativity property of this one, that's simply a disjunction, we have negation of P or Q or what? R. So that the statement which is equivalent to that of this one could be negation of P or Q or R. So that the answer for this one will be alternative B, but the rest or simply the others are not equivalent to the given proportion. So let us proceed to the next one. That is question number 3. Which of the following is not a proportion? A proportion again, that is a statement whose truth value is either true or what? False, that means. For example, if we see the alternates one by one, 3 is an even number. And it's clearly a proportion, which is true proportion. B, it is a country in Africa, which they is ambiguous because it, we don't know what or simply which or simply who is represented by using that of this one, that's simply it. And the next one, that's simply 27, is a prime number. It's again proportion. And the last one, that simply Albert Einstein was born on 29 July 1890. It's also proportion. So that the only possible thing which is not a proportion will be this one, that simply B, because of the ambiguity, that simply because we don't know which whether a country or simply an individual is represented by using that of this one, that is it. So that because of this ambiguity, it is a country in Africa, cannot be answered by using that of true or simply false, so that this is not a proportion. Therefore, the answer is B. Okay, next. Question number 4. Let P, Q, R, and S have truth values true, false, true, and false respectively. Then the truth value of negation of P and Q, if and only if P or negation of R implies S is blank. That is, in order to determine the truth value of this logical implication or compound statement, we only substitute the corresponding truth values for each component statement as n. We have to apply the rule of the logical connective involving here. That is, and if and only if and implies. We know that first we have to determine the truth value of the compound statement which is enclosed by the square brackets. That means, sorry. For example, that's simply P and Q means the first one, that's simply this one. We know that P is true and Q is false, so that true and false is false. So that its negation will be, the negation of false will becomes false statement. They hit the first one, and the negation of false is true, and P or negation of R, that's simply for this one. The truth value of this one could be, the truth value of P is again true, and the truth value of R, the third one, that's simply this one, that's true, but its negation will be false, so that true or false will be true. Okay, next. Let us combine these two together by using that of logical by implication. We know that when two propositions are connected by using this one, that's simply by implication, so that the compound statement will becomes true if and only if both these two have the same truth values. But when you observe here, both these two have the same truth value, so that true if and only if true is true again. So that the truth value of the compound statement enclosed by the square bracket is true. But what is S? S is false. So that true implies S is this one, that's simply true. True implies S is equivalent to true implies false, which is false because the premise here is true, but the conclusion is false, so that this is false. Therefore, the truth value for this one or simply this compound statement, depending on the given and the truth values of the given proposition P, Q, R, and S could be this one, that is false, so that the answer could be automatically false. Okay, the next one could be question number 5. it says again about the let the subset A the subset of B and B is the subset of C. Suppose A is an element of A and B is an element of B, C is again an element of third set, that's simply C. Then it says which are of the following proposition must be true. We know that this one that simply A is a subset to be the subset of B if each and every element of A is also an element of B. Similarly, B is a subset of C whenever every element of B is also an element of this one that is C. So that from the given information here, if A is an element of A must also be an element of B because A is a subset of B. It is also the subset of this one that's simply C because if A is the subset of B and B is the subset of C, A is also subset of C. That is transitivity. So that when we see the options, first one is since A is the subset of B and B is the subset of this one that is C, we know that if A is an element of A, this implies A is an element of B, and again A is also an element of C, because A itself is also a subset of this one that is C. But other alternatives are not guaranteed or simply cannot satisfy or simply cannot be true. Therefore, the only option that could be true will be that is C, that is A is an element of C. Question number 6. If A is any set and P of A that is the power set of A, then which of the following is not necessarily true? We have and the set that simply set A is any set, and P of A that's the power set of the given set A. Then what we are asking here is we are asking just to justify which alternative from the following is necessarily true. We have the option. The first one is that simply empty set is an element of power set of A. We know that power set of set A is a set containing the set containing all the possible subsets of the given set. And we know that empty set is the subset of any set. So that empty set could be an element of the power set of any set. Therefore, the statement that empty set is an element of power set of A is always true. Second one, empty set is the subset of power set of set A. Just as I've told you earlier, that is because empty set is the subset of every set, power set of a set is also a set, so that empty set is the subset of power set of set A is also always true. The next one, that is A is an element of power set of A. Because we know that power set of a given set is the set containing all the possible subsets of the given set, and A itself is the subset of itself, so that A must also be an element of its power set. So that this must also be always true. But number of elements of power set of A is greater than that of 1 is not true. Because just we are informed here that A is an empty set. If A is any set, so that if A is empty set, so that when A is empty set, the number of elements of the given set is 0, so that to the power of 0 is 1, so that 1 could be the minimum number of elements of the given set, so that greater than that of 0 fails to be that of 0, so that this is the answer for the given question, that is question number 6, so that the answer is D. Question number 7. If true star false is false, then the logical connective replacing star could be what? Remember the property of that of the logical connective. First one is that simply the first alternative is implication. We know that if we replace implication in the place of star here, it becomes true implies false, which is true. So that a star could be can be replaced by implication. A logical connective that's simply and. If we replace this star by and, we know that true and false is also false, which is identical with this one, so that logical connective and can also replace this logical connector, which is a star. If and only if, because these to have different truth values, so that true if and only false is false, so that by implication can also replace or simply this one that is star, so that all the given alternatives can replace this one. Therefore, the answer for this one, this question could be, and that is true. The next one is the last, I think the last question for this multiple choice item. Question number 8. If asymmetric difference b is equal to this one containing these elements and a minus b is containing these two elements 0 and 3, then which one of the following is not true? We are given the two sets, we are given two sets A and B whose symmetric difference is this one and their difference is 0 and 3. Then which one of the following is not true? Let us see the analysis here. We know that b minus a is equal to minus 1, 1, and 4, because we know that asymmetric difference is this one and a minus b this one. Therefore, if we take the range that of 3 from this one, or simply the symmetric difference, because the symmetric difference of this one is a without b union, b without a, so that b minus a could be this one, that's minus 1, 1, and this one that's simply 4 without the range that of 3, that is without a minus b. So that is true. B, number of elements of b is greater than 3. Number of elements of this one that's simply b is greater than or equal to 3, because already here b without a, even b without a is equal to this one minus 1, 1 and 4, which is exactly 3 elements. There may be other elements which are common elements of b and that of a, so that exactly the number of elements of b is maybe greater than or simply is exactly greater than or equal to that of 3. So that is also true. The next one, the number of elements of set A is greater than or equal to 2. Because the number of elements of this one that is asymmetric difference B is this one, and A without B is this thing, that's simply true, on only 2 elements, so that this one that is number of elements of A must be greater than or equal to that of this one that's 2, so that it is true. And the last one, this one that is A intersection B, is the subset of the power set, or simply P of A intersection B is false. A intersection B is false. So that the answer for this one could be sorry, it is not B, rather this one, that's it must be D. The answer is D. Okay, the third part will be fill in the blank space with the most simplified answer, it says. And the first question which we are given here is the truth value of their x, there for some x, an element of R, and for every y an element of R, x times y is equal to y is blank. Truth value, is it true or false? That means. So in order to check the truthness or the falseness of this statement, if we can find that a fixed element that's simply x, which holds true for every y in satisfying the condition of this thing, we can say that the truth value of this one becomes false. But I mean true, but this will be false if we are not able to find any x or any real number satisfying this condition for every real number y. So because of the existence of this one that is x equal to 1, which is a multiplicative identity in the case of the set of real number, because the product of any real number by y is always the real number itself, so that's which holds true for every one element of R, so that the truth value for the given statement could be true. The next one is let u is equal to the set containing minus 1, 0, 2 radical 3 and 2.1 be the universal set. Then the truth value for every x an element of u, there are some y's an element of u satisfying the condition of x squared plus y squared is equal to 4 is blank. We have this universal set, so that depending on this universal set we have, for every x an element of this universal set, there are some y's within the same universal set that simply U satisfying this condition, that is equation of circle with radius that is true. Therefore, the solution, or simply when we check this one, for example, if we take one of the elements of this universal set that's simply x, which is equal to radical 3, we know that the square of this one is 3, but there is no any other real number that's simply y, which could be added. Need y squared is equal to 1, which implies y is equal to plus or minus 1. But 1 is not an element of u, and minus 1 is equal to an element of u. But because of the existence of this one, that's simply minus 1, this could be satisfied. But if we check, for example, that simply take 2.1. But when we check for x equal to 2.1, systematically, we know that the square of this one, that's 2.1, is 4.41, which is even larger than that of this one, that's simply 4, which is impossible because the sum of the square of x and that of y is exactly 4. But this could be that if the square of only one element, that's simply x squared, is greater than 4, which is impossible. Therefore, for every x an element of y, that is, if we take x is equal to 0.1, this universal set doesn't contain any corresponding element that's simply y, or simply any element satisfying the condition of this one whenever x equal to 2.1. So that's the truth value of this one could be that is false because of the counter example, that's simply when x equal to 2.1. The next question is question number 3. It says list down the elements of B containing the set that simply all x, say that x is an element of Z, x less than or equal to minus 3 implies x squared is equal to 9. Where we are asked just to list the elements of the set that simply set B containing this one, that is the solution set of this set. So that the solution could be if x is less than or equal to minus 3. That is, we know that x less than or equal to minus 3 implies x squared is equal to 9 is a logical implication. So that the truth value, or simply the elements of this beam, is the set containing all x, say that, making this logical implication to be true. The possibility for this logical implication to be true is that if the first one is false, the second, or simply x squared is equal to 9, may be false. But when x less than or equal to, or simply this minus 3 is true, for this logical implication to be true, x squared is equal to 9 must also be true. Therefore, if x less than or equal to minus 3 must satisfy x squared is equal to 9 implies x equal to minus 3 only. So whenever this one, that is x less than or equal to 3 is true, we have one element satisfying this condition, which is minus 3. The next one is when we assume that this one is false. That is, when x greater than minus 3, this implication is vacuously true actually. Therefore, any element which is greater than that of minus 3 could be an element of this one. Therefore, totally the elements of set B could be the set containing minus 3, minus 2, minus 1, 0, 1 to that of n real number larger than that of this one. Therefore, this is the set containing this, in the set containing, or simply the elements of the given set, that is set B, satisfying this condition, that is x less than or equal to minus 3 implies x squared is equal to 9. Okay, question number 4. It says let A and B be two sets, say that A includes B, then A minus B union B is equal to blank. So in order to determine operate this operation, we have to have these notations. We know that A includes B means B is a subset of A. There is A minus B, that is a set containing all x, say that x is an element of A and x is not an element of B. So A minus B union B, that is the union of the difference between the two sets, and the second set, that is set B. Therefore, using that of the pictorial representation or Venn diagram, this one is set A, that is the circle which is containing the elements of set A. We know that B is a subset of A, or A includes B, so that totally B must be within the larger set, that's simply set A. Therefore, these two sets or simply circles can satisfy the condition A includes B, means B is the subset of A, or B is included or inside of A. Then this green region, that is the difference between the two sets, that is A minus B. This is A minus B, the green region, so that elements in A, but it's not B. That is just between these two circles, that is it, the green region is a region representing the difference between A and B. That is those elements that are included in A, but which are not an element of set B. Therefore, their union, that's simply A minus B, that's simply the green region. Union B, which is the red region, will give us the entire circle, that is the larger circle, the circle of set A. Therefore, A minus B union B is exactly equal with that of the larger set, that's simply set A. Therefore, the answer is A. The next one, that is question number 5. Let A and B be sets of the universal set U, and A intersection B is equal to empty set. Then A complement minus B complement is equal to blank. That means the difference between the complement of two sets A and B whenever their intersection is empty set, or when they are disjoint sets. That means we know that if the intersection of two sets are empty, then these two sets A and B are said to be disjoint sets. Therefore, the solution will be A complement minus B complement means the complement of A intersection, the complement of B. That we know that A minus B is equal to A intersection B complement. We have this relationship. Therefore, this could be the complement of complement is the original set, that's simply set B, so that A complement minus B complement is A complement intersection B. Since the two sets are disjoint, that is A intersection B is equal to empty set, this implies that exactly B could be the subset of A complement, because they are disjoint. So A intersection A complement intersection B is B, because B is the subset of A complement. Therefore, the intersection of these two, which is A complement minus B complement, is B. Therefore, the answer for this could be, that is B. The next one, that's question number 6. Let A is equal to -1, set containing 0 and 1. Then A minus the set containing 0 is equal to blank. The solution will be, that is the first one, that is A contains -1, the set containing 0 and 1, that is it has 3 elements. And the set containing 0 is an element of set A. It's included here. But 0 is not an element of set A. This 0 is not an element of A, but the set containing 0 is an element of set A. And therefore, removing this one, that's simply B set, will change A. Will change the elements of this one, that is, it decreases by 1 element. That means if we remove it. But since this one, that's simply empty, that is the set is given here. So that removing the row leaves A unchanged because the row is not an element of this one. So that if we remove this one that is in the row, so that the set given set that simply set A will not be changed. Therefore, the answer for this one will be the original set itself, that is set A. That is set A will not be affected by taking the difference between the set itself and the set containing this one, that's simply 0, since 0 is not included here or an element of set A. Okay, the last part for this mid exam could be a part 4, that's workout part or simply workout item. The first problem for this one could be about argument, validity of an argument. It says investigate whether the argument P implies Q, R or negation of Q, negation of R gives this one negation of P is valid or not using a rule of inferences. What we are asking is, we are given this argument and we are asked just to investigate or simply verify the validity of this argument using a rule of inferences. Therefore, the solution will be, or simply the proof will be using that of a table. We have the first one that simply P implies Q is true. The first premise, because 1, 2, we have 3 premises and 1 conclusion. The conclusion is negation of P. P implies Q, R or negation of Q, and negation of R are premises. Second one, R or negation of Q is again true, since it is a premise again. Next, negation of Q implies R is true from to here. We know that R or negation of Q means it is identical with negation of Q implies R, because when you take this one, that's simply the negation of this thing. That is, we know that this one is negation of R implies negation of Q. We can write in that case. So that the heat equivalent, that is negation of Q implies R, is true from this one, that's the equivalency of step 2. And third one, P implies R is true. P implies R means using syllogism, that is just transitivity. We have here in the first case P implies Q, which is true. And in the third one, we have also here that is P implies R, which is true. So that, negation of Q implies R. We have P implies Q, negation of Q implies R. Therefore, P implies R must be true. There is a rule of syllogism. Then the fourth one could be negation of R is true, since it is a premise, which is here. And then lastly, we have negation of P is true, which is modus tollens. From these 2 steps, P implies R is true, negation of R is true. If this one, that's simply this one is true, so that P must be what? It must be false. So that the negation of this one that's simply false could be, and this one that's simply true. Therefore, they hit the conclusion. Therefore, the argument is valid. Okay, the last question, question number 2. In a group of 50 students, 26 take economics, while 12 take both economics and psychology. If there are 10 students who take neither economics nor psychology, how many students in the group take only psychology? Then the solution will be, what we are given here is number of U, that is the expected universal set for this one will be the group of the number of students in a group, that is 50. Number of elements of E, that is taking economics, could be 26. While this one, that's simply intersection B means students taking both economics and psychology is 12. And neither this one, that's simply 10 students who take neither economics, that is the union of the complement of the union of students taking economics and psychology will be 10. Then what we are asked here is, we are asked just to calculate the number of students who in the group taking only psychology. Then, first, let's find the number of students taking both economics and psychology. That is the union of these two will be this one, that's the number of the universal set minus the number of the union of this one, that's simply students taking economics and psychology, which is neither, that means. So it becomes 50 minus 10, which is, we have 40. And in order to find the number of students taking only this one, that's simply P, which is psychology, number of A union P is equal to number of E, that is just the formula for the finding the number of elements of the union of two sets minus the intersection of the two. So that 40 minus 40 is equal to, that we have 40 here, that is the number of E union B, 26, number of students taking economics. We have number of P, which is unknown here, and their intersection, that is intersection P, the number of students taking economics and psychology is 12. So that this will give us number of elements, or number of students taking psychology will be this one, that's simply 26. But our question is just to calculate or simply know the number of students taking only psychology without taking economics, that means. So that's to find number of students who take only psychology, number of P without E is equal to number of P minus the number of the intersection of the two. The number of the intersection of the two is given to be calculated here, that's simply 12. And number of P, that's total number of P, including taking both chemistry also, we have 26 here. So that number of P minus E could be 26 minus 12, which is equal to 14. Therefore, 14 students will take, or simply take only psychology, and without taking, that is economics, that means economics. So that the answer for the problem could be and that is 14. Okay, that is all about the questions of the mid-exam. So I do have some takeaways. Quantifier, set of operation, logical equivalence. In the case of quantifier, which for counter example with universal quantifiers, set operation of definition of symmetric difference and power sets. The case of logical equivalence, master implication laws and truth values. Venn diagrams, which is very important for the proof of problems related to that of set operation especially. And then proof techniques, practice inference rule, and validity checks. Just a second way of proving validity of an argument in addition to that of truth table. And the common mistakes that should be avoided, that you should avoid here will be confusing element and subset. Element means for a single set, if we are given, and then that is simply any set, so that the elements with an element there, so that this could be something, a symbol which represents, or simply just to explain the belongingness to the given set. But in the case of that of this one, that's simply subset. It is the relationship that is in between two sets. First set or simple set can be the subset of the other whenever if all the elements of the given set is also an element of second one. Then misinterpreting quantifier order. We have two quantifiers, that is existential and universal, so that their order is very important for the truth value of quantified proposition, so that we have to avoid this misinterpreting. Forgetting the empty set in power set counts. You know that power set of a given set is the set containing all the possible subsets of the given set. So that empty set is also a subset of any set. So that empty set must also be an element of the power set of any set. Incorrect converse inverse formation. For a given logical implication, we have an inverse, converse in that of contrapositive, so that we have to avoid again this incorrectness. Overlooking vacuous truths in implications, that is implications, logical implications. That is all. Thanks for watching. Don't forget to subscribe this channel for more videos like